Hello, geometry. This is 11.5, volumes of prisms and cylinders. So remember, prisms have a top and a bottom. So there's no pyramids with this one. We'll get that in the next lesson. Okay, so prisms and cylinders, they are similar in that you have a top and a bottom, and then you have either 4 sides or 5 sides or a surface going around it right there. So one thing that is assumed is that we recall and we remember the volume of a right prism. Now, a right prism is not just one that's not wrong, but a right prism is when the height is also the altitude. Okay, so a right prism is when the height equals the altitude. Okay, and there's not a slant height. Sometimes a slant height, like you'll see shapes like this right here. And we'll be looking at these right here. These are called oblique cylinders or oblique prisms, okay, because they're leaning a little bit. These are not right ones. So here, this is the altitude, it's not the height. This is referred to right here as the slant height. Okay? So that's what we're looking at here, but it's no different. The formula is still the same. Volume equals the area of the base times the height. And you can come up with lots of different unique formulas for this based off whatever shape you have, but it's always going to be the same. Okay, so for any prism or any cylinder, it doesn't matter whether it's a right one or it's twisted like this. Okay, the volume is still going to be the same. The volume of this shape on the left here on page 334 is the same as the volume as the one on the right. They've just taken it and shaped it. They did not lose any of the pieces in there. Okay, so the area of the base, I wrote down a lot of the ones. A lot of them you'll probably remember, but these are kind of the shapes that you're going to have. You can have a square prism, usually called a rectangular prism, or a cube. Square prism could be a cube. Okay, may not be. A rectangular prism, so the area of the base would be s squared for a square, length times width for a height, for a rectangle. A triangle would be 1/2 base times height of the base. Okay, that one can get kind of tricky because you can have okay, there's your triangular prism. Make sure your base and your height, if this is 3 and this is 4, and this can be 8. So this would be 1/2 times 3 times 4. There's the area of your base times your height. Okay, then you take it times 8. This would be a cylinder, a circle base. Trapezoidal prism, number 1 actually deals with this formula here. You have a prism that is the shape of a trapezoid. It has a base, so 1/2 of your height times the sum of your bases. Okay, and remember your bases are the parallel parts. So base 1, base 2, the height has to be perpendicular to your bases. Okay, and the polygons show up again. 1/2 of your apothem times your perimeter. Perimeter can be the number of sides you have times the side length, n times s. Okay, so pause that, get those formulas written down if you need those. So what we're looking at for these, this is a oblique cylinder prism, okay, or oblique cylinder. We don't need a cylinder prism. Oblique cylinder. So we want the area of the base times the height. So if I have a circle for there, that means my volume is pi r squared times height for this particular shape. Okay, the r would be 2, pi times 2 squared times 3. So 4 times 3, that'd be 12 pi. And that would be about 37.7. And that would be cubic inches. Volume is in cubes. We have a cubed relationship between the 3 dimensions. Okay, you're multiplying 3 dimensions. You have the r squared, and then you have the height. So consequently, if you would double your height, you would double your volume in this case. But if you would double your radius, you would take your volume times 4 actually, because the radius is being squared. Okay? And if you double your height and your radius, you'd be cubing this relationship here. Okay, you take it times actually 9, 2, 4, 8. Take it times 8. Okay, 2 cubed. Okay, so look at that a little bit later. Okay, another oblique cylinder. The height is 15. There's your height. There's your radius. So we're going to use volume equals pi r squared h. So pi times 5 squared times 15. So 25 times 15, we have 375 times pi, which is about 1178.1 cubic centimeters. Okay, cubic centimeters. So area of the base times the height, you have to find the height. Okay, some of the vocabulary. We've already talked about a lot of this. Similar solids we'll talk about later. Density is mass divided by volume. That's how you get like grams per cubic centimeter or kilograms per cubic inch. You probably wouldn't mix metric and English. So we could go pounds per cubic foot. All of those would be labels that would be density. Okay. So the volume of a prism, volume equals base times height. B is the area of the base. H is the height. Okay, so that formula doesn't change. We've already done a couple of these cylinders here. Find the volume of the cylinder. So you just take, here's your radius, and there's your height. So volume equals pi times 2.5 squared times 7. 7 times pi, 175 over 4 pi, so that's about 137. I think a lot of your answers they want into the hundredth. To the hundredth, that'd be 2 decimal places. So 0.44 cubic inches. Okay. Here you're going to use the 11. The 11 is the height of the object. Okay, it's the altitude. So volume equals pi times 2 squared times 11. So that's 44 pi. 44 pi is about 138.23. That'd be cubic centimeters there. Okay, a few things with words. I haven't given you the picture. Find the indicated measure. They want the height of a cylinder with a base radius of 8 inches and a volume of 2010 cubic inches. So now they're giving you the volume. There's your V, and they have an R. They want us to find H. So if they give you a shape, what you have here is you have a radius of your base that is 8 inches. We don't know our height, but we know the volume is 2010. Okay, and it is a cylinder, so volume equals pi r squared h. So 2010 is pi times 8 squared times h. So if you're solving for h, you have to divide by this whole thing here. So h would be 2010 divided by the quantity, 64 pi. Make sure that's in parentheses. And we would get our height to be about 10. So I'd say it's about 10 inches for our height. So solving for other variables, that's going to come up in a lot of the other ones. The area of the base of a pentagonal prism with a volume of 50 cubic centimeters and a height of 7.5 centimeters. They want the area of the base. They're not asking for a specific piece of it. They just want the area. So if I have a pentagonal prism, I have the area, I have a pentagon on the bottom. How about that? Does that look okay? There's my pentagonal prism. Okay, and I know the volume is 50. So that's, if I fill it with water, I need 50 cubic centimeters of water, whatever. And my height is 7.5. So volume equals the area of the base times the height. And that's all they want here. They just want the area of the base. So 50 equals B times 7.5. So B is going to equal 50 divided by 7.5, which is 20 over 3. Okay, probably round to the nearest hundredths, so that's about 6.67 square centimeters. They want the area. Area is units squared. Okay, units squared. So some pictures with the same sort of thing. Find the missing dimension of the prism or cylinder. So here's a prism. They give you the length. They want us to find the width, and here's the height. So I have a rectangular prism, so volume equals the area of the base times the height, and if I have a rectangle, I have volume equals length times width times height. So I know the length, I know the height, I need the width. So volume equals 18 times the width, which is y, times the height, which is 3.5. So I'm going to take the volume, which is 661.5, has to equal, let's see, 18 times 3.5, put those together, 63y. So I'm going to take 661.5 divided by 63, and I get 20, and that's 10.5. So y equals 10.5 centimeters. Okay. A cylinder, here's the volume. We know volume equals pi r squared h. So 75.36 equals pi p squared, p, that's the r, times 6. So I'm going to divide by 6 pi. Put those two together, divide by 6 pi, and that's what p squared is going to be. But then to get the squared off, you have to take the square root. So p is going to be the square root of 75.36 divided by 6 pi. If you can put that all in the calculator like that, you should get the right answer. If you're doing this piece by piece and you're rounding answers as you go along, you're going to be off by the end. So do not round answers until the end. Square root of 75.36 divided by the quantity 6 pi. And we get 2. So p equals 2. So the radius there would be 2. A few more examples that you need. I missed these. Oh, I completely skipped this page. It's wrong side up. Let's do the volume of the prism. Here is a triangular prism. Okay, so you have to do, here's your base, and there's your height for that. So volume, and this is the height of the prism. Okay, so think of it's 1/2 base times height times, I'll call that the capital H, the big H. Okay, so imagine this is actually standing on its end. So we have to take 1/2 times 3 times 1.5 times 5. So we get 1/2 times 3 times 1.5 times 5. And you get 11.25 cubic centimeters. Here they give you a pentagon. They're just telling you the area of the base is 10. So volume equals the area of the base times the height, so that'd be 10 times 4, that's 40. We like those. 40 cubic inches. Woohoo. Okay. So there's the volume of the cylinder formula, which we had. Similar solids. Two solids of the same type. That means they both have to be pentagonal prisms or square cubes or cylinders, with equal ratios of corresponding linear measurements. Linear measurements are your radiuses, your lengths, your widths, your heights, all of those things, such as heights and radii, are called similar solids. Okay, so it's basically the same shape, just different sizes. We know that definition for similar. The ratio of the corresponding linear measures of two similar solids is called the scale factor. If two similar solids have a scale factor of k, then the ratio of their volumes is equal to k cubed. Okay? So if their sides have a scale factor of 2 to 3, that means the volume will have a scale factor of 2 cubed over 3 cubed, which would be 8 over 27. So if I have a cube and it's 2, 3, 4, and then over here I have another cube that's bigger, and the scale factor is 2 to 3. So if I have 2 here, I have 3 over here. Okay, so let's just say Okay, I had some other examples. Let's look at those. So here, yeah, this is what I was trying to get to. So here's my similar solids. And they're saying, okay, this volume is 80 cubic inches. And you notice they want the volume for this without actually figuring out what the height is. Now with the cube, it's kind of easier to do that, but here we have 4 to 2. You see how this is half the size of this, okay? So the scale factor here is 1/2. So the scale factor of the sides is 1/2. For every one of these, you have 2 of these. For every one of these, you have half of these. Now you have to cube the scale factor of the sides to obtain the scale factor for the volume. So I'm going to take 1 cubed over 2 cubed, and I get 1/8. Okay? And that's going to be the scale factor for this one. So if this volume is 80, I'm going to take 80 times 1/8, and I'm going to get 10. The volume here should be 10 cubic inches. Okay? Because what you're doing here is if we set this up correctly, the 80 corresponds to the bigger number because it's the bigger shape. So 80 from the shape over a scale factor of 8 has to equal V, the volume of that. So we have volumes here, we have the scale factor here, over 1. So there's your 1/8. The 1 went under the smaller shape, the 8 went under the bigger shape. Okay. So if we look at this one and they tell you these are similar solids, we have 2 cylinders, this has a height of 5 and this has a height of 8. So your ratio of sides, for every 5 on this one, you have 8 on this one. Which means for the volume, you need to cube these, so 5 cubed over 8 cubed, which would be 125 over 216, 512. 125 over 512. Woo, big. Okay, that means for every 125 cubic inches here, you have 512 cubic inches here. So how we're going to set this up is we're going to have the volume for this one. So volume over the scale factors. So for this one, I have a volume of 72.8. I'm going to put that over, this is the smaller shape, so I'm going to put that over the 125. And that has to equal the volume of the larger shape over the scale factor from the larger one, 512. So you're going to double pickle it. We're going to take 72.8 times 512 and then divide that by 125, and we get about 298.19. 298.19. So 298.19. That's kind of how you set it up. You look for your scale factor here. You have to cube it to get your scale factor for volume. We did this with area, and you had to square it because area is units squared. There's 2 dimensions that go into area. There's 3 dimensions that go into volume. Okay, then you set up volume over the correct scale factor equals the other volume over the other scale factor. The other example I wanted to cover with you is sometimes they won't give you the height, but they will give you the slant height. And you have to remember your 30, 60, 90 rules again. Okay, they're coming back into play. So they want the volume of this. Let's say this is a square prism. It's an oblique square prism. I had it written up there. We need the volume is going to equal the area of the base times the height. So if it's a square, we know the area of the base is 5 squared times the height, which we don't have that. But they did tell you this is a 60-degree angle here. So if this is 12 inches, that means this is 12 inches. You see the 30, 60, 90 that we have going on here. So if we go from the hypotenuse to the short leg, we have to cut that in half. So if that's 12, this is going to be 6, which makes our height 6 root 3. Okay, those properties for 30, 60, 90s, look those up again. So we have 25 times 6 root 3. 6 times the square root of 3. Whoops. Yep. 25 times 6 square root of 3. And we get the volume to be 259.81. 259.81. Okay. So that should be it. There'll be a few other things that some of you can chew on. Starts off volumes of prisms. There's your trapezoid. 1/2 of your height times the sum of your bases. There's the height of the prism, the 2. Volume of the prism, volume of a prism. Here's a triangular prism. Your height is right there. There's your base and your height, the 7 and the 10 for the base. Cylinders, find the volume, round it to the nearest hundredth. This is, they're giving you an equilateral triangle, and each base edge is 8. So you have an equilateral triangle that has each side of being 8. Use your 30, 60, 90 rules to find the height of that base. Okay. Pentagonal prism with a height of 9 feet. Each base edge is 3 feet. Okay. This goes back to the previous lesson. Draw that pentagon, and you have to find the height, the apothem. You'll be looking for that. So pentagonal prism, height of 9 feet, each base edge is 3 feet. Find the volume, round your answer to the nearest hundredth. These are finding the missing dimensions. Okay, again here, this is a hexagonal prism. This one's harder than what it looks like. They say 2 inches across here. You need to find the area of this base. Okay, area of a hexagon with a side length of 2. Find the missing dimensions. These are your relationships. So it says, okay, this one's 9, this one's 3. This is 1/3 the size, which means it's 1/27th the volume. Cube them, okay? And then one composite figure. So that's it. Good luck. Let me know what questions you have, and we'll talk to you later.